buzzing.
I remember the first talk that Dan gave on this subject. There was a tremendous feeling of excitement at that time. Dan managed to break away from this endless gathering and classification of rocks, and he really brought the thinking of a physicist to the problem and brought order to a very confused part of geology.
The key to understanding melt generation within the Earth is to understand the physical processes involved. Historically, this is not the approach that geologists have used to understand volcanism. If we're to do this, we must...
Mackenzie realized that, like the man who cannot see the wood for the trees, geologists have been confused by the sheer variety and detail of volcanic processes. He believed that there was an underlying simplicity which could be expressed with all the rigor of mathematical equations.
I think the thing that distinguishes people with a background in physics from the geologists is that what they want to do is to try and get at the simplest form of the system which still has the features that they're interested in. And by doing that, you get a long way, to throw away all the complications, which are essentially complications but unnecessary to the real guts of the thing.
The guts of the problem are simply this. Why does the Earth produce so much molten rock? Although volcanologists had a good understanding of what happens in the crust, just below a volcano, Mackenzie wanted to understand what was going on much deeper within the Earth, at their very roots. The challenge was to unravel what goes on far deeper than anyone has ever drilled, in the region geologists call the mantle, where most of the molten rock must ultimately come from. The first clue, as so often in science, was a paradox. In 1964, a great earthquake devastated the Pacific coast of Alaska. The sea floor rose several meters, creating a huge tidal wave. Shock waves traveled thousands of miles through the Earth's mantle to reach recording stations all over the world. The shock waves gave seismologists vital information about what the mantle is like. For the waves to travel so far and so fast, the Earth's mantle had to be literally as strong as steel. Solid rock, in fact. So there were no vast lava lakes within the mantle, waiting to be tapped. This was a major problem for scientists like Keith Cox from Oxford and Asit Jolly, a paleontologist from the University of Chandigarh. For 20 years, Keith Cox has been a regular visitor to India to study the Deccan Traps, one of the largest volcanic formations in the world.
So what's the route?
What we've done is we grab a bite somewhere.
I think we've had a pretty good idea at the time that the Deccan Traps, which make up the Western Ghats,